And I hope the online guys can hear me. That's the question we are going to start with, which is based on the concept we have discussed in the previous talk. And the question says there's a time space diagram, the one that you see on your right, where x-axis is the time, y-axis is the space. And let's say this is 100 meters, that's 250 meters. What you want to know is what is the observed value of the flow rate at 130 meters point in the space between, let's say, 5 seconds to 55 seconds. So what's the flow rate we are observing there? Okay, that's, I don't know the answer, maybe that's the answer. And what is the average headway at 130 meters? So 2.38. Okay, well, we'll see. In fact, if I would have not asked this question and I only say what is the average headway, students get confused. They think they have to estimate the headway from here, individual vehicles, and take an average. But technically, you don't have to do that individual vehicle once. You just take the flow rate or get the volume, convert into flow rate, and do the average from there. So there are around 21 vehicles in 50 seconds. So it's around 1512 vehicles per hour. Yeah. And the average headway is inverse of that, 2.38 seconds. It's pretty simple question. It can be further, I would say, made complicated by saying that the solid line represents, let's say, cars, the dotted line represents bike, and so the thick one, let's say, represent bus. Then we can express that in terms of passenger car per hour per lane. So you can make it more complicated, which we are going to discuss when we're going to do the tutorial today. So that was the warm-up thing. I want to discuss about the average speed. It sounds very easy that average speed is just an average speed, but in traffic engineering there are two separate concepts: the time mean speed and the space mean speed. I will be honest, when I was undergrad, I didn't understand the difference between the two. It took me a while to understand when I have to teach to my students. So we go back to the average speed as the generalized definition. Average speed is always total distance traveled over total time taken. That is the generic definition of the average speed. Now, when we say the space mean speed, it means that a mean speed over a space. So you are fixing your space. It can be a space mean speed over a section of the road. It can be a space mean speed along the entire corridor. So the space is fixed. So when you say space means speed, means space is fixed. So let's estimate the average speed from there when we are fixing the space. Let's assume that each vehicle has traveled an equal distance d. I believe it is going to work that way. Okay, I don't know how it works. Let's assume that the vehicles are traveling an equal distance d, right? Now the time taken by the first vehicle to travel a distance d, let's say the speed is v1. That should be the first one actually. Let's say there are three vehicles. One is at a speed of 30, second speed of 20, and third speed of 10. Just for the sake of explanation, I'm showing you three different speeds, right? So v1, v2, and v3. So the speed of the first is v1, second is v2, third is v3. So what should be the time taken by the first vehicle in terms of v1 and v? Oh, okay. There's a marker. Oh, okay. That's okay. I will use my pen here. So what do you think is that one? So, oh, sorry. So if this is the distance d, if speed is v1, speed of the first vehicle is v1, speed is equal to distance over time, right? So time taken for the first vehicle should be the distance over speed v1. Same thing should be for the other vehicles, right? Distance over speed v2, distance over speed v3. From here, you can simply find the total time taken, which is sum of all these. So I can say the total time taken is summation of distance over the speed vi, where I is whatever the i's are, right? What is the total distance traveled? Each vehicle is traveling a distance d. So total distance traveled should be whatever is the number of vehicles. Let's say n is the number of vehicles. In our case, n is 3 multiplied by d. Average speed should be simple total distance traveled over total time taken, which will be nothing but n over 1 over vi. So you might have heard that the space mean speed is the harmonic mean of the speeds, right? That's how it comes from. We have fixed the distance. Are you okay with this? Then the time mean speed. Apply the same concept. What do you get? Yeah, so now the time is fixed. They'll say that each vehicle is not traveling for the same time t.
V1 into T, V2 into T, V3 into T divided by NT.
It will be simply what? That like that t's
Arri-
cancel out.
Yes.
Like in the previous case,
Arithmetic mean.
the d's have cancelled. So I didn't mention here, but the d's have cancelled out. So that's why you have the harmonic mean, right? But the d's were out. Same thing will happen there. In the other case, the first one will be v1 times t, second will be v2 times t, and so on. Total distance traveled will be summation of vi times t, which is nothing but t times summation of vi, right? Total time taken will be n times t. So average speed will be t times summation of vi divided by n times t, which is nothing but the arithmetic mean of the speeds. So whenever we say what is an average speed, the first thing that comes into your mind is just taking an arithmetic mean. But that is not the speed you are interested in. That is a speed which is assuming that the time is fixed. When I say what I mean by time is fixed means if I fix my time like this is my time window. Now what's happening is the first vehicle or the last vehicle has traveled that much distance in that time. First vehicle has, in fact, has traveled a much larger distance. So distance traveled by different vehicles are quite different in that time interval. So that speed, the mean speed, is not the speed you're interested in. If I want to know, or if I want to say what is an average running speed along this section, I am fixing my section length. Whereas if I take an arithmetic mean of these three speeds, the first vehicle has traveled all the way there. Second vehicle has traveled until here. The third is until this point only. So arithmetic mean will not be a true representation of the average speed for that corridor. Under what conditions it will hardly matter whether it's arithmetic mean or it is the harmonic mean. Same speed. If all of them are traveling at the same speed, there is not speed variations between the vehicles. Arithmetic mean is same as the harmonic mean. It doesn't matter whether you have taken arithmetic or you have taken harmonic. It will give you the same value. But fundamentally, you are wrong. I mean, in terms of calculating the speed. So if you are writing a program which is just taking arithmetic mean, there will be instances when the speed variations will be there. Here, I mean, this is an example where imagine there are 3 lanes, right? And the 3 vehicles are moving at 3 different lanes. So, and we have seen in the previous plots where we show the space-time diagram, different lanes have different speeds. So your speed variations are there. Along the same lane, yes, maybe they will not have a dramatic variation, but among different lanes you will have. Are you okay with this concept? Yeah. Let's try to solve this question. Straightforward question is there. Now, so what is the time mean speed? If I give you 3 speed, what is space mean speed? Sorry? Okay, maybe. And second is first not 60, first one 63.2. No, so it's the wrong one I put here. My bad. You are no. This is the answer for the next question. Yeah, it may be 60 perhaps. Yeah, you're taking arithmetic mean then. So the first one you have taken arithmetic mean, second one you have taken harmonic mean. That's all, right? Okay, can you tell me the true values? First one is 60. What is the second one? Sorry? Yeah. Generally, space mean speed is always less than or more than the harmonic at time mean speed. Less than. Yeah. That's another thing. I mean, so the harmonic mean is always less than the arithmetic mean. Now that was the answer was for this question, second one. Like if I have 5 vehicles traveling at speed of 70, 3 vehicles at 62, 2 vehicles at 48. Now what is the space mean speed in this particular case? Don't worry about the time mean speed, space mean speed. So imagine you have 3 lanes. On lane 1, you have observed 5 vehicles traveling at 70. Lane 2, there are 3 vehicles traveling at 62. Lane 3, there are 2 vehicles traveling at 48. So 3 separate lanes. I want to find the average speed of the entire section. Let's say 1 kilometer section. Space 63.2. Time mean speed. Okay. What does space mean? Okay. Yeah, perfect. 63.2 and 61.9. Yeah. If you're interested to read a bit more about it, there is an off-road guide on traffic management directly you can read, where you have more details about what I've discussed. Now I'm going to talk about the fundamental diagram or fundamental relationship between speed, flow, and density, or the headway, spacing, and speed. Keep in mind the speed there is the space mean speed. So it's not the time mean speed. So fundamental diagram, the fundamental relationship, you all know that Q is equal to K times V. The density flow is equal to density times speed. Never forget that. That's the primary equation you have. And normally when I teach to my students, I never give them this equation to undergrad students. They should know that. And in fact, you should know the units for each one of them also. Always keep the units in your calculation. If the flow is expressed in vehicles per hour, density is expressed in vehicles per kilometer, the speed has to be in kilometers per hour. Sometimes you might have different units, and if you do not take care of the units, you will screw up the answer. Now, I'm going to talk about the macroscopic modeling part of it. When I say macroscopic modeling, means I want to look at the macroscopic relationship between flow speed, flow density, and the speed density. There are two things, there are the two terms that you should know. One is the free flow speed, which is the speed under the free flow condition. Hardly anybody on the road, the speed at which you are driving, but that should be close to the speed limit of the road. Second one is the jam density when the traffic is fully jammed, bumper to bumper. And we asked earlier that what is the spacing during the jam condition? If the spacing is 5 meters, then the jam density is 200 vehicles, on average 200 vehicles per kilometer per lane. So please keep in mind it's a per kilometer per lane. So if the number of lanes have increased, your jam density has also increased. Now let's try to sketch the fundamental diagram. I'm quite sure almost all of you should be able to sketch it, except those who are new to this traffic engineering one. X is the density, which is the concentration on the road. Y is the flow. Can you sketch the diagram for me, please? How does that diagram really looks like? Okay, parabola is what you have learned, but think about what it can look like. And for those who are quite new to this concept, think like this. Early in the morning, nobody's on the road. You will have almost zero vehicles, density will be zero, almost close to zero vehicles flowing, so flow will be zero. You will be having one point here. Think of a jam condition, fully jammed, bumper to bumper. Nobody is moving. Flow will be zero because nobody is moving. So you're not observing anything. So you will have a jam condition and density is the maximum. So you have two boundary points with you. Now you can sketch the shape. Parabola is what is a simplified version, but you might not have the parabolic relationship. When you do a parabola like this, it is a simplified way of representing it. In that particular case, your critical density is almost half of that. So if your jam density is, let's say, 200, critical density is 100, which is not what you observe. So it is more shifted towards the left, right? So again, I'm going to use it as a parabola here first for your understanding. No, I'm not using parabola. It is a shifted parabola actually, but it is parabolic relationship. The maximum flow rate that you are able to get is the capacity of that specific section. It's a maximum flow rate. So generally, if you are able to express it in a parabolic form, the slope should be zero there. What can you say about the slope of this line? Sorry? Speed. No, the slope of this line. From origin, if I draw a straight line like this, the slope here. What is it? Sorry? Traffic speed? Or what form of speed? Free flow speed. It is free flow speed. If I draw a line from origin to any point on the curve, I will get the slope of that line is the speed. Because q is equal to k times v, and you get the speed from there. That's fine. That's what we have learned. We have also learned that the maximum capacity and the density corresponding to the capacity is the critical density. Why? Because before this traffic, these are the images from the highway capacity manual. Nobody on the road, maybe this point. Some traffic on the road, maybe that point. Some more traffic on the road here. As you move forward, when you reach to the jam condition, bumper to bumper jam, right? So this images were just to show that how the traffic can be there. So that's why this point where you are on the other side of the road, here the flow is increasing as the density is increasing, flow is increasing to the point where you reach the capacity. But after that, density increases, flow starts decreasing. That's why you call this as a congested region, this one as a uncongested region. A simplified way of expressing it. Can you plot between speed and density now? Think of how the plot looks like between speed and density. Sorry? Asymptotic, yes. So when there's no traffic on the road, somewhere here you are at the free flow. So you will be at a free flow for a while. It's not like you start decreasing. Maybe 5 vehicles, 10 vehicles, 15 vehicles, the density is increasing, you're at a free flow. After a while, the speed starts decreasing. So there's almost a straight line that starts decreasing, keeps on decreasing until you reach the jam density. So it is something like this. Of course, you can simplify it as a straight line, simplify it as some other form, but that's one of the forms that you get. This diagram we are going to use a lot when we're going to do the variable speed limit. I'll come to that. How does it goes back? I'll show that to you how it goes back. This is there. So if it comes here, it goes back like this. We will see how it looks like. Then draw the diagram between speed and the flow now. Speed flow relationship. Yeah. Speed and the flow, how does it look like? Yeah, okay, good. Same thing, the boundary conditions. hardly any traffic on the road, flow is quite low, speed is free flow. You have a free flow speed for a while, then the speed starts decreasing as the flow starts increasing. You reach the capacity. After this, things move in the congested region, and you get a curve like this. So the maximum flow rate is the capacity, the maximum value, and again you have a critical speed, the speed at which you reach the capacity. Upper portion is uncongested, below portion is congested regime, right? And then this one was to share that if a flow rate is given to you, you cannot say much about the congestion on the road, because if you look at a specific flow, that flow can be low because of the uncongested condition, can be low because of the congested condition. So flow is not a good indicator for congestion. Is speed a good indicator for congestion? Yes, it is. If you know for what time and what section the speed is. So if I say the speed limit of the road, or sorry, if I say the speed on the road is 40 kilometers per hour, but if I do not tell you what road it is, what was the speed limit, it has no meaning. If it was an arterial, the work zone speed limit was allocated as 40, and people are driving at 40, it was fine. So the speed limit is an important thing to know. But yeah, flow is not at all a good indicator for congestion. Density, um, as was told in the previous lecture, is one of the good indicators for congestion, because this is something you feel, and we have seen that density is hard to measure. Other thing is the slope of the line that you see here joining origin to the speed flow diagram, that is inverse of density. If you apply Q is equal to K times V, the slope of this line will have a gradient of inverse of density. Now, that's a question that we have. Let's say x-axis is density, y-axis is the flow. Units are quite fine, vehicles per hour, vehicles per lane. What is the speed at 7:45 a.m. in the morning? So what's the average running speed of that location at 7:45 a.m. in the morning? How much? Yeah. So it's somewhere around 7,000 divided by 150, right? Whatever the value comes in. Good. Now, this is what we have learned in undergrad level. Let me now bring to some real world examples here. This is from one of the motorway sections in the city of Brisbane, and you have different loops. I've not talked about the loop detectors yet. I'm going to talk about it in the next lecture. But let's say somebody is standing here and observing the traffic flow and giving you an estimate of the density, which called as occupancy, assume that is known to you. It also giving you a speed value. So I'm getting that speed, flow, and density. Actually, I'm getting a speed, flow, and occupancy at 315, 319. In fact, all these locations, right? I'm actually getting that. So this is the fundamental diagram I'm plotting for 319. X-axis is occupancy or a proxy for density. Y-axis is the flow. That's what we're observing at different time intervals. So around 7:58 in the morning, this has gone up, gone down, coming back here, and so on. That is a real observation shown as a step of time. So one of the points that you have raised, if the hysteresis is there, you can see the hysteresis. Traffic goes up, then comes like this, reverses back. So there is a loop happening. It doesn't go in the same order in which it has gone the other way around. Yeah. In fact, this is a spatial fundamental diagram where you have the variable speed limit activated. So do not worry about the speed limit information, which I did not manage to generate the other plot. But this is what you have right now. Okay, and I'm right now focusing only on the fundamental diagram. That's one. And what is the next one? And it's for the whole day, and you can see how the flow values are changing. So this is the flow value. That's the speed limit of the road for that time interval. Now speed is back to 100, and you can see, and this slope should be the slope of 100. You can see the vehicle, the maximum capacity is here, and there is some drop happening. We discussed about the capacity drop also. We will have a similar plot for the. No, why the both of them didn't start together. I wanted both of them to start together. Similar plot for the speed and the flow. And you can just observe that. In speed and flow, the traffic goes like this, it comes down, and this is around maybe 8 a.m. in the morning, and then it might be coming back again. And now when the way it is coming back, is just came back like this. There is a hysteresis happening. But if a traffic, although we have learned a parabolic form, what you have learned is just a generic shape. But actually the traffic is going in the other way around. Now this hysteresis is very important. But when you're applying the control, depending on whether the congestion is building up or the congestion is dissipating, you are in the different regions. And this is from the real observation. So a loop on the road every 1 minute, you're getting these values, and I've just plotted those values. Any question on this one? So if there is a work zone, yes, so you have basically either you might have reduced the speed limit will have changed. If speed limit has changed, then basically you will have a different diagram for the speed limit, right? So that is, in fact, this section, the previous speed was 100. But if the section was a work zone for long, and you've already reduced the speed to 60, for example, for that section, the diagram will be at a slope of 60 then. So it will go, so basically the speed limit will change the way the plot is, right? If that work zone was just happened halfway through, which is same as the one you see here, the speed limit was 100, it went to 90, it went to 80, 70, 60. Well, it was not because of work zone, it was because of some traffic control measure. So your fundamental diagram shape will change. What will not change is this part of your fundamental diagram. But that is because of congestion. This is a fundamental diagram for speed and occupancy. So the previous ones was for speed and occupancy. That was speed and flow. This is for speed and occupancy. The speed is pretty much constant here, and then starts decreasing, and you can see the way it is coming. Now the change is happening because of the variable speed limit one, but technically it is going like that, and the recovery will happen this way. Yeah, so that's the hysteresis you are actually observing in this condition. This is for one location only one location. This is 319 outbound, only one location. It's not about the stretch of the road, it's just one location you're observing. It's a single point observation only, right? Different diagrams, depending on the characteristics of that location, depending on the speed limit, depending on the number of lanes which are there, depending on like the curvature of the road, if the road is curved or not. So there are a number of factors. You will not have the same diagram for all. Different days will have a different shape. You have a rainy day, shape is different. You have a normal day, shape is different. Shapes are different. That's what I'm going to discuss. I'm going to talk about how to interpret means what. How do we use this? Yeah, I'm going to discuss it, but I'm going to talk about the variable speed limit. So the reason I have shown this is this will be the foundation for my discussion on the variable speed limit. Actually, that's for the speed limits. So as I said, do not worry about the speed limit here. Here, the concept is not to talk about speed limit. Concept is just to talk about the shape of the fundamental diagram. Because when you have seen in the books, you might have seen a spread, but you might not have seen the way it is changing over time, right? And fundamental diagram is very important concept. You have to have a good understanding of it. In fact, there's a lot of traffic flow theory research on this where they are trying to come with the shape of the fundamental diagram. So what equation to fit in? They are single regime models, multi regime models, try to define the shape. Now those fundamental diagram shape equations are very important. You want to mathematically express this. Why do you want to do that? What's the importance of that? Can you give me, sorry? Forecasting, yes. What else? Prediction, what else? Modeling, simulation. So if you're developing a simulation model, for example, cell transmission model. How many of you know cell transmission model? Okay, it's a you know cell transmission. It's just a mesoscopic model. So you're saying I have a road divided into different cells, and I want to simulate how traffic is moving from one cell to another cell. Okay, so there are equations for it. If I have time at the end of the lecture, remind me. I will talk about cell transmission model also. So it basically, so when you want to mathematically express the traffic going from one cell to another cell, you need a relationship between flow density or this one, and you need to have a mathematical relationship. That's why you try to fit a curve properly. Now you can have any curve. You can simply think of a parabolic form, but the end objective is to replicate the traffic behavior. If you're simulating something, you want to replicate how traffic behaves. So the accurately you are able to capture the fundamental diagram, the better you are able to replicate the behavior. So I showed you, let's say I showed you two time space diagrams, where I showed you one diagram when there was no RAM metering, other diagram when there was a RAM metering. Okay, I should forget about those RAM metering things. Say the one diagram is what you're observing on the road, second diagram is when you're simulating the road. If you think that way, you want to develop the equation so that your simulation is as close as reality. So that's where all the scientific research, there are hundreds of papers on that, where people have tried to get the shape of the fundamental diagram, so that you try to replicate the behavior as much as possible. There are various models. I didn't put the equations here, and maybe I will get the slides for that one also. There are a number of equations for it, and then you try to calibrate the fundamental diagram based on your observations. Like a simple one that was discussed earlier, or somebody was talking about what happened. So here you can think of like a parabolic equation after certain frequency speed. That's a simple one. Other one you can think of after certain speed there is a linear equation. It's up to you how you want to model it. So, and it depends on the application. What is the end application? You don't want to have a very complex model for some simple application. So the modeling needs defines what model you want to actually fit in. Sorry about this. The screen freezed. Okay. Now somebody asked me the shape of the fundamental diagram, right? That how the shape changes. Or do we observe the same shape everywhere? This is the work I did when I was doing my PhD. So I'm using the slides since then. In Lausanne, Switzerland, there was this from one of the loops in that area. X-axis is the flow, y-axis is the speed, and I think it was 1 minute flow speed they gave it to me for the whole year. And you just plotted them for fine weather and fine weather, rainy and snowy conditions. So I've just color coded or just changed the shape of the dot point based on what type of weather it is. What you can see here is that somehow the shape is like this during the fine conditions. Shape might be like that during the rainy conditions and the snowy condition. As the weather impacts, your capacity starts decreasing, your free flow speed starts decreasing also. You might have a different shapes accordingly. So weather is one of the important, I would say, contributors of the shape of the fundamental diagram. And in fact, when I'm going to talk about the variable speed limit and the future research directions, I want to talk about the impact of weather. That weather is something that really we have to look at, how the traffic behaves under the adverse weather conditions. And during those conditions, we have more accidents on the road. So, and the traffic management is very important at that point. Are you fine with this shape, or do you have any question? Do you think this is not the right shape? Now, that was a fundamental diagram that you draw at one specific location of the road. And different locations might have a different fundamental diagram. Later on, I will show you diagram for multiple sections of the entire motorway. So the motorway section I was showing to you, we have diagram for all the sections. I will show that to you. Interesting thing is, if I look at my area, if the area has some properties, some characteristics, then if I try to accumulate my densities and accumulate my flow or the tip completions, I might get a similar shape for that area. So let's say this is an area I want to look at, right? And this area has some similarities, or I would say this is not very, like it is, the densities are quite consistent. You'll get a shape like this. That was a concept introduced a couple of years back, where we call this as a network fundamental diagram or the mesoscopic fundamental diagram. So if I have different links, different sections, I continue accumulating them, get the accumulated density, accumulated speed, we get that shape. Do you think that this thing can happen? Can you get this kind of shape? There's a lot of research in the macroscopic fundamental diagram space that actually people have worked on. Do you think this shape is possible? Or the shape should be something like this? Let's have a look. So when this actually this MFD work was introduced to me, um, I asked one of my PhD student at the time to generate the MFD for the city of Brisbane. So don't worry about how we get flow and density. I will discuss that when I'm going to talk about the loop detectors and how we fuse loops with the Bluetooth to get the density and all those things. Assume that somebody is able to give you density. Just assume it for this point. So this guy integrated loops, Bluetooth together to get the density value and to get the flow values and so on. We divide the entire Brisbane into 4 regions, as you can see, 1, 2, 3, 4, and we have the data from all the major roads there, and we try to generate the fundamental diagram. We want to see the empirical fundamental diagram, and what we get was something like this. And this is from the real data set. This was quite old work in 2011, 2012, 2013 time period when I just joined QUT. I was moving from EPFL, and Professor Nicholas Gerolimus just joined EPFL. And I had some chat with him, and his PhD was on MFD. That's how I had some interest to explore that. So he introduced the concept to me. I went, and one of my PhD student, I asked him, can you just help me to generate a fundamental diagram, empirically fundamental diagram? It was quite new research at that time. Now it has been very well established. And this is what we observe. X-axis is the average density, y-axis is the average flow. And we only got 1 week data. I remember that time I sent the student with a hard drive to the Brisbane City Council to actually get that data set. We only got 1 week of data set from the loops, from the Bluetooth, etc. One interesting observation we found. I mean, this is for 7 days, and you can see each color represents one of the days. On 23rd of October, we found some scatter. I asked him to go back and check whether the data is correct, whether his code is fine, and he spent like a week of his time. He said everything is fine. He was confident. So then what's happened? Why we are having a spread for only 1 day while the other days are okay? So then he went back and he started looking at further. There, yeah, there is some interesting observation he's finding on 23rd of October, 6 a.m. It is deviating. 8:30 after 8:30 is coming back in this region. Same thing is happening somewhere. A scatter is happening around that time period. Well, that's fine. I asked him to check the database of accident something, and this is just the courier mail, like it's one of the newspaper in actually Brisbane. He found that look, there was a major accident on one of the roads. The truck crashed into the house, but that crash happened somewhere around 1 a.m. in the morning. That's okay. There's not much traffic. It took a while for them to remove the truck, and this newspaper says that around 8:40 a.m. the council worker and emergency service successfully removed the truck in what police have described as a delicate operation. So that data is clearly showing that the report was fine. So it is saying 8:40, around 8:30 we are observing the recovery in the system. So the one I was saying that when you draw the fundamental diagram for one section, you have one shape. You can accumulate sections, you will have another shape. They may not be same, but the shape is the functional form is still the same, and this is well verified from that angle. I mean, even like any fundamental diagram will have its own disturbance, right? Here, accident happened, capacity has gone from bad to worse, so your speed has significantly dropped, and then it is moving in that manner. In fact, similar to the one which we discussed, if I draw my average, or if I have a diagram of speed, sorry, flow and density, the slope of the line is the speed, like the one that you found in the previous example. We can do the same thing. The slope of this line, if I draw from origin to any point there, it is the average running speed for that section. If I look at this whole area for which I have drawn the fundamental diagram, around this specific time, let's say the slope is 120 by 60. Let's say 120 by 60 is how much? 20. Average running speed is 20 kilometers per hour, which is what you observe in the arterial network anyways. So the slope is the average running speed for the entire section, and that is the space mean speed for the entire area for which you have drawn your mesoscopy fundamental diagram. So obviously the speed has dropped. That's why you can see all the deviations happening. So generally at this time, the speed was whatever it was, maybe around 30, 60 by 20, 30. And we're observing on the articles, even if the speed limit is 60, you'll not be driving at 60. Speed was 30. It might have gone down to maybe approximately 25, and so on. So there's a lot of work people have done in this space. One of the work that a lot of work that they have done is a parameter control. So if you want to control the traffic in a region, when you want to control in the sense that you say this is my region where I'm going to hold and flush. Means I'm going to hold the traffic first and then let it flush. So you want to see how many people should be moving from here to there. So at a strategic level, when you're doing the control, this diagram can help you to make those decisions depending on where you are. Theoretically, it has advanced a lot, but to my knowledge, I don't think it has been practically implemented because of the challenges you face in generating the fundamental diagram. You have to collect so much data set to actually place it, and the scatter is there and all those things. But it's an interesting concept that, like, when you talk about a link fundamental diagram, the same thing goes to the whole network also, given that the network is homogeneous in terms of its congestion. If the network was not homogeneous, you will not have this kind of shape. Yeah. So that was for MFD. Now, let me discuss another interesting, important concept: the self-degrading behavior of traffic. Like when I was talking about the volume and flow rate, I asked the flow rate is different for different time intervals. Only for 15 minutes, the flow was of the capacity, and we want to manage that because that is going to create some issues. Why? Because the traffic has a self-degrading behavior. It means that at the local scale, the capacity drops as soon as the congestion sets in. We have seen the fundamental diagram, the capacity drop happening. So your capacity has dropped. At the global scale, because of spillback and blocking, the network traffic also goes from bad to worse. If I am having a system congested, is going to block my upstream intersection. The traffic which has to move, which is not even have to exit there, might still be part of the traffic, and that is going to increase the congestion. Let's have a look on this. I don't know why we have it here. That's fine. This is, let's say we have two scenarios. One is, so we have two funnels, and you have 1 kg of rice grains, and you want to pass that 1 kg of rice grains through the funnel. In one case, you are slowly pouring the rice so that at the bottleneck or the neck of the funnel, there is no congestion happening. Other case, you just pour the rice here and let it go. Let's say it takes T1 time to let 1 kg of rice pass. It takes T2 time to have 1 kg of rice pass. Which is more time? T1 or T2 are the same time, or no? The rice amount is same number of particles. Which is going to take more, and why? So which one, T1 or T2? T2, why? Speed, okay. I mean, you will have, okay, you are pouring here, you are pouring there. Let's say the drop is same, but here you have poured in a very streamlined manner, so that you are not able to obtain that condition here. What's the reason why you have more time for scenario 2 than scenario 1? Yeah, flow is actually okay. Flow is high actually here, but because in this particular case, different grains of rice have to compete to enter this funnel. There's a friction happening. They're going to, fight against each other, and that's the one which is going to drop the flow and the speed. So you have a lower flow rate, you have a lower speed, you have a much higher density here. Density is quite low. You can see that, right? Same concept. I'm giving you an example now on a motorway section. That's the bottleneck. Imagine the same as the funnel. Bottleneck from 3 lanes, from 4 lanes, I'm going to 3 lanes. Let's say the capacity per lane is 2,000, for example. So we have 8,000 capacity upstream. We have 6,000 capacity downstream. Right? It's a totally hypothetical scenario. Let's say your input is whatever it is. Let's say the input is 5,000. You might be able to flush that 5,000 out under certain scenario. Purely hypothetical. Yeah. Let's say 5,500. Imagine nobody's changing lane. People are so disciplined. They are just driving, and they're driving on the lane, 3 lanes. You might be able to flush 5,500. Everybody's following the rules of one after another. 6,000. Again hypothetical. Everybody is following the rule. You might be able to get them out, right? In reality, it will ever happen. The moment you are close to 55, people will start doing a lane change. Things have gone from bad to worse. But hypothetical case. Now, if I have a bit more traffic, what's going to happen is, no matter whatever I do not have the capacity for them to go away. They have to join the queue. They have to queue there because of the limited capacity. You will have a queue formation. We have seen that when the queue forms, there's a drop in the capacity happens. So now, earlier I was able to serve 6,000 vehicles per hour. Now I'm able to serve only 5,700 because of the drop in the capacity. Because of the friction happening here, the capacity drops. And that capacity drop can be very high number. It can be 10%, 20%. Even in the Indian condition, it can be even higher perhaps. So capacity drop is happening. So at the local level, the traffic has gone bad. Earlier, I was able to serve 6,000, and now I'm only serving 5,700. If the demand is increasing, or even if the queue is actually building up, what's going to happen here is that's a capacity drop. The queue spills over is happening. The moment this queue exceeds the off ramp, this is the off ramp, the traffic has to go away from here. All the cars in this region who were supposed to exit now basically part of the queue. So they are going to add more to the condition. So what's going to happen is this portion will have an increment significantly. So at the global level, traffic has also gone from bad to worse. The ones who were supposed to exit are no longer able to exit, and they're adding to the congestion. Yeah, that's the reason that 15 minutes example I gave you, that okay, 15 minutes the capacity was or the demand was more than capacity, can cause congestion for let's say an hour or so. Accidents happen on the road, and the road agencies try to clear that road as early as possible. Why? Because obviously you want to go there and serve the patient, but you want to actually clear the lane, because that is going to add a lot of problems. Accident happened here, congestion is up till this point here, but when the congestion goes further up, it's going to block the network. It can choke the network. So I hope you understand the concept. Why do we need to perform we take some measures so that we don't go from bad to worse. I'll take an example. Generally, it will. I mean, because when you drop from 3 to 2, sorry, from 4 to 2 or 3 to 2, it's a natural bottleneck. It's a quite natural bottleneck, right? Because I have 4 lanes there and I have 3 lanes here. So if the traffic is going there, all the traffic on this lane have to do the lane change. They cannot go through, right? So this, no, even if there is no queue, let's say even this example, 5500, 5500, it will never happen. 5500 is less than 6000, but that 5500 was spread. And when they are approaching here, they have to do the lane change. And the lane change, as you guys have mentioned, is the reason for congestion. Any abrupt lane change is going to create shocks. So it is a natural bottleneck. So some portions of the road network where we know there is a drop in capacity is a natural bottleneck. Yes.
In that case, would you suggest constructing flyovers is creating more bottlenecks?
It's a quite constructing flyovers. I know that flyovers are really the political decisions in various parts. I mean, when I was like in 1998, when I was in Lucknow, and I was thinking at that time, a lot of flyovers being constructed because because you don't have enough space around. That's the way to go. Yes, the point where the traffic has to enter is the point where you will have the congestion and naturally happening, accidents happening. So when you're constructing a flyover, is you or any infrastructure you are developing, you have to look at the bigger picture, not just that point. So if you have a, let's say there is a railway line, and that railway line is causing congestion because that boom gates have to go up and down every, let's say, 5 minutes, for instance. So naturally that portion will have a traffic queue happening, and one way to address that is to develop a flyover, and that's the right decision, because now people don't have to stop there every 5 minutes. But if that flyover is developed, you have to look at the bigger picture also, how the demand is actually moving around. So perhaps instead of developing a flyover there, if you would have addressed or given them an alternate route somewhere else, the demand would have spread out. So that's where the large network modeling plays a very important role. When you build a model for the large network, like simulation models, you try to test different scenarios. You try to see, okay, if I go in option A, what's happened? If I go for option B, what's happened? And these simulations you can do like even without building anything. And you have to do that to build up a case. So whether you answer constructing flyover is adding more construction, I don't know. It depends on the how and where it has been implemented. Yeah. Learnings are there. Definitely learnings are, but again, each and every each and every city is unique. You have to look at multiple things, but the learnings can definitely be transferred that are there.
I wanted to add. So in this, like whatever example he has shown, like 4 lane to 3 lane. So even if you see that, like in many of the our cities, like even though we have 3 lane facilities, but in between there will be, due to local parking or due to local certain other encroachment, we will have these kind of bottlenecks, and that kind of uh, perception wise, we feel that this is a small stretch which is covered or like encroached, but that is actually causing this entire capacity drop for entire stage. Like if one place, if you had pressed the pipe, so then entire flow get impacted irrespective of even if you widen subsequent route, so it is not going to solve the purpose.
Yes,
Yeah.
that's actually a good point. So maybe let's say at this point some vendors are here, even though you have extra lane, but that is the bottleneck happening. We call that bottleneck because it looks like a bottleneck.
Side friction studies are also based on similar concepts of bottleneck.
I'm not. I don't know much about the site friction studies. The one that they might be doing is more about to understand how the travel time and other things are there. So
The
you know,
basically how they at the
Hmm.
table is there.
Yeah.
If you remove the
site frictions, but yeah,
then how
Hmm.
but how actually the traffic
Yeah.
So is it like the same concept of like bottleneck only?
Yeah, because a site friction is going to actually what happens again. It depends what level of modeling you are doing. If you're doing there are different levels of modeling. Microscopic modeling, you try to model individual cars on the road network. Mesoscopic modeling is the cell transmission model I said. You try to model the traffic as the flow from one section to another section, right? So, and then the macroscopic is the post travel to one modeling. But between micro and macro depends on the problem at hand. So, when you are doing this mesoscopic modeling, which normally we should be doing for the Indian condition, because you should start with the mesoscopic first, then before going to the micro, because micro has far more parameters to calibrate because you are trying to capture the individual driver behavior. Whereas in the case of mesoscopic, you are capturing how traffic flows from one to another. So in that case, yes, a side friction will create a bottleneck. You will think of the fundamental relationship at that point compared to the other ones. So if I divide this whole road into different cells, right, then I will have certain characteristics of my fundamental diagram here compared to the other one. So the diagram I've shown here, let's say, is for this point. Diagram for that one might be different. Diagram for some other place will be different, but I will show you those for the entire stretch of a motorway section, how the shape really changes. But yes, you have to understand the traffic behavior there to do that kind of modeling. So I was not familiar with what kind of study you're talking about, but in general, yes, that's
Side friction, what generally in Indian condition we consider, like say if there is a bus stand on the side of the road where bus is going to stop, so that also creates like maybe occupy some space, that will create one side friction, and sometimes like you have on street parking,
Okay.
so that also create regular side, especially on like say habitat area, like maybe there's you have rural highways, but like if there is a market in between, you will have lot of side friction, there will be temporary parking on the side of the road. So people use that to understand that if the length, depending upon depth and length of the side friction, what kind of impact in capacity drop. So for that, generally people do microscopic modeling.
Okay.
So develop like some kind of reduction factor and those things. So whether that is you are talking about side.
Okay. Thanks, Akhilesh. Yes. Good question. Yes, I mean intersection in itself is a controlled traffic one. So you have. I will ask you a question. How does the fundamental diagram look like an intersection? I have got the. I asked my one of my RAs yesterday to generate a fundamental diagram for intersection. He has sent me an email. I'm not opening the email yet. So I will show you how it looks like from a real data set. But can you think of how does the fundamental diagram looks should be for intersection? So let me go back. Then I will answer your question there. Let's say this one was a fundamental diagram at this location. Now imagine instead of here, let's say I want to draw the fundamental diagram here. This is the intersection, right? That's the motorway section. That's the intersection. How will the fundamental diagram for this section looks like? It's a very good question you have asked. I wanted to actually ask this to you guys when I totally forgot. How will the shape look like? I mean, fundamental diagram is never continuous. You have seen that spread out, right? But how will the shape look like? I'm talking about shape. How will the shape looks like? Sorry? So when at this point of time, when the traffic is fully, like the signal is red, flow, obviously flow is 0, speed is 0, right? Yeah. But in general, how the shape will look like. Now, what's happening at the intersection is you are giving green time and you're giving a red time. You are saying, oh, I'm only let these guys enter the intersection where the signal is green. But when the signal is red, they should not enter. They should stop, right? So in 1 hour, let's say I'm only giving green for 50% of the time. So then naturally the capacity is already 50% of whatever it is. So this fundamental diagram, the one you see here as a capacity, it will be bounded from here. So shape will be something like this. So that portion that you see here is the capacity of the road network. So it will be truncated from here. Now I might present tomorrow to you what he has given to me, because I asked him to download the data from one of the intersections and generate the fundamental diagram for me. But that's how it will be. It will be a cut here, a trapezoidal shape. Obviously, the points will not be like, if the shape is like this, but the points will scatter everywhere, right?
But if we go with the situation flow, why capacity should be because if we will be talking about what capacity during green time.
Then it's another table you have raised. How will the shape looks like if I only plot my data points during the green time? So let's say I'm only going to calculate the flow and occupancy during the green time. At that time, I will not do any calculation. So let's say I have a green for 60 seconds, red for 60 seconds, then green again for 60, red for 60. Only present the data for the 60 seconds. It will have somewhat shape the way you see, perhaps. But if you do it for the whole 1 minute data point, average flow and speed, the flow is naturally zero during the red time. So the capacity is lower.
Yeah, if we consider average, then it will come down.
Yeah.
During the red signal, all the data will be on rightmost side.
Rightmost side.
Jam dense.
Yeah. No, but the thing is, imagine there was no intersection. Then this whole thing is able to flow as the way it is flowing. Then the capacity, let's say, for each lane is, let's say 1800, just for the sake, let's say 1800 vehicles per hour per lane, and there's only one lane. So you will have a 1800 there. But if you have given the green only for 50%, that will be 900. So it will be bounded from this 900. Free flow speed will be like this, 900 boundary and the other way around. It's a very good question you have asked. It came to my mind yesterday when I was thinking about the slides. Okay, I should have got a fundamental for RTL also, and hopefully he has given me enough to show you guys. Otherwise, yeah. That's good. So this is where we talk about the capacity drop. If you're interested, you can watch this video. I mean, this video is the same thing which I showed to you. It's a quite interesting video where it shows that actually there is a capacity drop here. I'm going to give all the slides to you guys, so link will be there. You can watch it later on. Now, we talked about a generalized speed for fundamental diagram. Generally, the way it is expressed is something like this. This is, by the way, from the highway capacity manual. So you have a free flow speed until a certain point. After that, the speed starts decreasing until you reach that capacity. Then this is your discharge flow, and that's your capacity drop. And then you have a congested region. Why I'm showing this? Because we try to use this kind of relationship to come up with some logic behind the control of the traffic. And different speeds will give you different diagrams. If you drop the speed, you have something else, and so on. This part I'm not interested in. I'm interested in this part when I'm trying to control my traffic, because if I'm in this region, things are already bad. You can't do anything. So only when you are in this region, I want to do some kind of a control to be more of a proactive. Okay. This question I think you can easily answer. But roughly, what is the capacity drop here? How much is the capacity drop? That should be this one, right? So if let's say this is around 4,000, let's say this is around maybe 3,300 or 3,500. So it's a 500 drop. So 500 over 4,000, maybe around how much? 20%, 20%. So that's the amount of drop you're observing on that section. Yeah. So it can be 10%, 20% depending on the site and depending on the traffic conditions. Yeah. So that's all I have for the traffic flow fundamentals. We'll take maybe 5 minutes pause. I mean, you stretch yourself, but feel free to ask me questions. Then we will start the next lecture on, or the next topic, actually, not the lecture, on traffic data sources.
Anything you can tell us about toll gates?
Sorry?
I've observed that whenever you approach a toll gate, at least in India, the road started to
Widen up? Yeah. Mhm.
so that's a compensation for the upcoming.
No, because that's the way you can manage the traffic. You try to wind it up because they have to stop and go, and then you have a toll operators also there, and you try to spread it around because when the vehicles are stopping and going, a lot of emission is also happening. So you really need to make the traffic safe and then also safe for the employees there. Whereas if you look at e-tolls, like if you go toward the electronic tolls, you don't need to have that widening.
Yeah.
It's only because of that manual toll collection you have to do that. That winding is because of the manual toll collection. You have a manual person standing or a person there collecting toll, traffic is stopping, going, a lot of pollution is for that guy. And then you need to wind it up because you need to spread them around multiple lanes. So if you spread them around multiple lanes, you can serve more people in, and then they can join the traffic later on. So it has to do with that, I would say, the service level. If the service level is not there, if you can have a smooth flow, you don't need that.
You can coordinate with whatever he has discussed about the
Mhm.
signal, where you are blocking for some time,
Mhm.
opening for some time. So for some time, like the way you are stopping and then activating, you are losing something.
Mhm.
So basically, you can assume that that is a right time where nobody is moving. So capacity, like you said, the capacity is reduced. So that's like the existing 4 lane road, whatever capacity now, if you put toll, capacity is
We had a coffee break at 3:30 or 4:30.
widen the road so that like one third, you are making 3 such channels so that you will be able to serve same capacity. Because at the end, this side of road, this side of the road, capacity has to be same. Otherwise, there will be queue which will keep growing over time.
What?
That is why you
Should we check with them? We had a coffee break. Should we have a break or we should start now? I'm fine. Maybe I will start here and then we do it for, yeah. That's good. So let's now start the transport big data analytics. Now we all know our transport system is actually a one complex multimodal transport network. You have different modes of transport here. Like you have, like in the case of public transport, you can have ferries, trains, trams, buses. Other important thing is you have different roadway facilities, motorways. This is actually one of the bridge where you have the pedestrians and cyclists, buses, micromobility, etc. It's a one complex multimodal transport system. I would also like to highlight different agencies are handling different portion of the network. Maybe for example, in Queensland, TransLink, which is a division of the Queensland Department of Transport and Mains Road, handles the public transport. So there is a separate division handling it. The Department of Transport and Mains Road is handling motorways and the nearby arterials and the major arterials the one having 3 or 4 lanes arterial road network. In the city of Brisbane, Brisbane City Council, the city council is managing your RTL network and also the facilities that you have for the micromobility. So there are different agencies who is handling different part of the network. Sometimes they are part of the bigger umbrella like the Translink and TMR, they are same at a high level, but they are different agencies. But you as a road user, I as a road user do not know about it. So that's one of the complexities that you have. These agencies have to talk to each other for them to have an integrated approach to manage the traffic. There is a willingness always, but sometimes there are some challenges with respect to the performance, with respect to the funding, etc. I can give you an example. For example, when you apply a ramp metering on the motorway, you try to control the entry of the traffic on the motorway. Motorway or expressway is managed by the state government, for instance. But when you try to restrict that entry, that spillover goes on the arterial, managed by the local government. They're not happy that why you are spilling the traffic on our network. So there are challenges. So when you are working as a consultant or as an engineer or as a researcher, you have to deal with actually various levels of these agencies. There is always a willingness to work together, but things are far more complex. That's why I think you as an academic, you as a professional can add a real value. You can bring them together and look at the big picture. The good thing is our complex multimodal system, which is a system of systems. I call it system of systems because there's not one system of systems. We have multiple data sources, at least in the developed part of the world, which is trying to observe the traffic over the network. You can have a loops, you can have Bluetooth, you can have incident records, you can have a public transport, GPS records, third parties like here in telematics, TomTom are also observing a lot of data set, taxi fleets, smart card, public transport smart card is a very important data source. Each time you touch on and you touch off, you are sharing a very, very valuable information with the road with the public transport agency. They can use that information to better manage the public transport network. So that data is available. Availability of this data set for the multimodal network gives you opportunities to have evidence-based decision support all the way from congestion management to the strategic planning of the network. Earlier, I have shown you a transport system cycle only for one. Now I'm showing it for the whole multimodal network. Concept is still the same. Now the things have changed. This is your brain. That's your data set. These are the different actuators. And that's your network. Are you okay with this? What I'm going to discuss now and later on tomorrow morning is on this part. Only on traffic data, because it's very important for you to understand the data set. If you want to manage or control the traffic in real time or even offline, the data is a very important input. Somebody was telling me in Bangalore, they are now using the automated signals, right? I think I forgot the names. I forgot the name. So he was talking to me, he's from Bangalore. They are now having a traffic signal control with loops and all those things, right? And automatic control. Even let's say you are controlling the traffic and you have a fixed plan specified for different time of the day and day of the week. Identifying what those time of the days should be requires analytics. You can manually go and do survey, or you have a data set available to you that can help you to identify the patterns in your entire time periods and then make your plans for different patterns. So there can be more, I would say, advanced ways of handling or more smart ways of doing it, but only when you have the data set with you. So big data was a buzzword number of years back. Nowadays, nobody cares about the big data because the data is data, but it is still, an interesting buzzword. But it is basically, as per the Oxford Dictionary, is a set of information that are too large or too complex to handle, analyze, or use with standard methods. I always quote one of the comments I got from one of my collaborators in the Department of Transport and Mains Road. I was talking to her about the big data, was giving a talk. She said that for her, the big data is if she can't open it in Excel file. That's the big data. That's true. It is big with respect to whatever you're doing. So for that person, If she can't open the data on Excel, it's a big data. For us, it's a big data because if the data is quite big, it's okay. But if you go and talk to the Facebook group or SADA, for them, it's a billions of terabytes is a big one. Or if you talk about the what do you call the video one where you have the video recording and you're trying to analyze and all doing the facial match, that's the big data for them. For our data is actually big, means it's large, but it's handleable. It's quite systematic. Whereas, but still, as I said, if you can't open Excel for some of them, it's a big data. So it's based on your current abilities. Is normally categorized as volume, velocity, and variety. Comes in a large volume, might have multiple variety. Like Twitter, for example, the Twitter feeds, right? They comes in a text form, unstructured one. And then you have the, let's say, video filmed records, different images. So it's a volume and veracity and volume, velocity, and variety is there. Other two V's, value and veracity, are important, which I always stress to my students and to whomsoever I talk. If you cannot extract the value from the data set, no matter how big the data is useless. It will just be storing a space in your computer. That's all. So you have to look at the ways by which you can extract the meaningful information from the data set. Otherwise, no matter how big it is, it's useless. Other important thing is veracity. If you don't trust your data, it's useless. If I don't have a confidence in my data set, I can't make any decision. Yes, I have a lot of information, but I don't have confidence in that information. I don't trust the source. I do not know how the data is collected. Is useless. So there are a number of V's in the big data that are important, and I want to highlight this. I want to highlight these two things because we do a lot of survey and we try to extract some information. And in fact, over the last couple of years, I've examined a couple of PhDs for the Indian condition. And one of the comments which I normally make in that when they have collected the data set, I say that, oh yes, you have done a good job. I would like you to make your data public. You have published a paper, you have got your, that's the comment I physically write, I definitely write in that one to the supervisor also. Why? You have got the value out of it, and once you have got it, make it public so others can learn from it. Over the last few years, my team has gone more towards reproducible research. Now, any paper we are publishing, I asked my team, yes, you put the paper in, you make your code public also. So your code should be made public, not just because it increases the chance of publication, but more important is anybody who's going to work on this topic should learn from what you have done. There is some resistance sometimes because you're exposing yourself, but that's fine. I mean, you might have done some mistake in the coding part. Let somebody else find it for you and then correct it. But please make it public. And I think in Indian condition, I have seen a lot of data being collected by various researchers over different part of India, but there's no centralized database where they can think of sharing it. And I think we should be sharing the data set. Once you've done there's a lot of value. I will tell you why. As an academic, those who wants to be in academia, or even if you don't want to be in academia, your research, when you have published, you would like somebody to cite it, somebody to use it. Otherwise, if you're in academia, you have published your work, good, for that year, you have reached your KPI, the key performance indicator. Yes, I have published 5 papers. Good, very good. But 5 years down the line, your supervisor will ask you how many citations were there, what is the H index. If that is not there, you're just shifting a problem from here to there. But if you have made your codes public, if you have made your data public, other persons, researchers are going to use it. They are going to find value. They're going to accelerate the process quite fast. And when they're going to do it, they're going to refer to your work. Naturally, it is going to add value to you. So I always encourage, in fact, I have said this number of times to various colleagues within India, whomsoever, make your data set public. Even if you're collecting it, make it public. Obviously, after doing your research, you don't want to just public at the beginning. Once you've done it, make it public. So that, I think this was distraction, but it's okay. It's important because few of you are academics, few of you might join academia. So it's important that you understand that one.
It's important. So velocity is very important.
Yeah. Yeah.
More thing is that use this data.
Yes.
The moment I use it, it will be resolved.
Yeah.
The structure concept.
And I'm going to talk about why. This is from my own personal experience. The veracity was the first thing came to my mind when the Bluetooth data was exposed. I'll discuss that now after this. In 2011, when I joined QT, Bluetooth, at that time, they were installing Bluetooth scanners. So Brisbane was one of the early adopters of the Bluetooth scanners. Brisbane City Council installed Bluetooth scanners at different intersections. And I used to go to their department in a hard drive to get some data set. And they were giving me data travel time values and so on. Very good. But I have no idea how the data is being collected. And I was thinking, okay, should I be using it blindly or should I be doing some work? So my very first paper after joining as an academic was on the fundamental understanding of the use of Bluetooth Max scanner. I did that research, and I'm going to present that to you guys today. That research helped me to have some engagement in India with Srinivas Arkatkar from SPNIT. We have some discussions on what can be done with the Bluetooth scanners. From my initial startup fund or the initial academic funds, I bought some scanners at that time to have understanding, because the department is giving me the data set. But if I buy the scanners myself, I can do some more fundamental research on it. So I have a couple of master students working on it to understand that one. So when I bought that scanner, it has both Bluetooth and Wi-Fi inside it. We didn't use Wi-Fi there. We only used Bluetooth. And because I was having engagement with SNIT, we brought some scanners here in India to do some study. What we found was that in India, we are having far higher Wi-Fi observation than what we are having as the Bluetooth one. So these things I didn't plan in the beginning, but and I think that data set, if you're able to have a Bluetooth and Wi-Fi scanner in Indian condition, you can have a really good data source available to you. So that is only because of this veracity. You have to understand what's behind it. So what I'm going to discuss now is the Bluetooth Max scanner. So let's go to that one. Shall we go? We take a break. Yeah. If not, then I will continue and we can take a break afterwards. But you can ask me some questions more. I mean, before I start this. If I start this, it will take a bit longer. Yes. Yes. Good question. Google is giving a lot of good data set. Google has a lot of speed information around the corridors. Yes, you can get that. If you're able to get it, definitely you should be using it. It's expensive to buy. It's a third-party data source. It's not a cheap one to have it. It is going to give you travel time only, or the speed along the corridors. It won't give you the trajectories and all those things because of the privacy concerns, and it's a large organization. I know that Google is doing some good work in I think it's the green light, if I'm not wrong. There's a project that they have where they are using their Google speed information from different sections to define the signal timings. And I think Bangalore is part of or some of the Indian cities are part of that. So they're doing some work in that space, that how you can use the Google traffic data to get the signal timings defined. But yeah, but it's very, you cannot get the Google data straight away. If you want it, it's very expensive. They're selling it at a much higher price. But it is only the speed you're going to get. Speed is just one source of data. I think one of you is working on traffic assignment. Who is somebody you are? For traffic assignment, you need to know the traffic paths, what path people are taking. That's where the Bluetooth data set is going to play a very valuable role, or the trajectory data set is going to help you a lot. In fact, in one of the future presentation, I will talk about what we have done with the trajectories to understand the route choice behavior over the network. So those information you cannot get. So in the case of Bluetooth, the whole intention to install Bluetooth was to get the travel time information. That was the only intention. But I will show you, apart from that, we have done a number of other works on that one. Travel time is just one piece of information. Now, Bluetooth itself, it's an interesting story. This technology was developed in 1994 by Ericsson, and they wanted to get rid of this wireless communication. So they wanted to get rid of the wires, actually, not the wireless communication. That's why this technology came in. Yeah. Okay, I'll freeze the slide and then we start. The name is derived after a Danish king, Harald patented Bluetooth Gorsam. Interesting story here is that this king was eating a lot of blueberries. Blueberries, his tooth were blue, and they used to call him Bluetooth. The engineer who was developing this, or that part of the team, he was reading a book on this guy and said, I'm going to name this as a Bluetooth. They liked it. It came Bluetooth. And the symbol here that you see here is the runic alphabets of H and B. So that is Harlan and Blatland. If you combine these two together, it becomes Bluetooth. Interesting thing, engineers reading book and giving the world a new name, a new technology, and a new symbol based on it. Quite nice. Yeah. By the way, this information is started from Wikipedia. I've used it for last 10 years. So please do not question me if this is wrong, but I think it should be right. It is not just from Wikipedia. I've read it number of other places also. It's a protocol. It uses the protocol for ISM is industry, scientific, and medical band. I'm not a communication expert. So there is certain, I would say, radio frequency band that they specify for this kind of technology, used by a number of other ones like Bluetooth, Wi-Fi, near-field communication, even the cordless phones, so that these technology don't interfere with the other technologies. So certain bands specified for them. The way it works is it works on the frequency hopping, because there is certain bandwidth or certain range against which they can send the signals. So it sends the signals in one frequency, then hop to another one, and so on, so that you don't have an interference happening. Right. So that's the introduction of the Bluetooth. I will talk about how the Bluetooth scanner works after the tea break. But we have a tutorial after that, right?
Yes. So maybe like before leaving, can we have one round of introduction? Because like
yes,
many of the
yes.
and that will be better. Like maybe starting from that corner.
Yeah.
So
that's a very good thing. Yeah, please.
So maybe you can use mic. I don't know, but like this is wired one. No. So 2-3 things basic, like your name, like from which place, currently what occupation you are, and maybe like if you can say what you are expecting from this course, very brief in one line.
Can I add one more thing?
Yeah, please.
Maybe you should also say something that not people know about you. One thing that you can come at the end. We can start when you come at the end.
Okay.
One single statement that people don't know about you.
So my name is Preeta. I'm basically from Kerala. I'm a PhD student at NITK Surathkal, and I'm working with Sri Kumar sir. And my area of research is dynamic traffic assignment.
Yeah.
So also I'm using some parts of optimization for some bi-level, network design problem kind of things. So that's why
I hope you will help me in the last lecture. I'm going to talk about traffic simulation with the bi-level optimization. Good. Yes.
Good evening. I am Arichandran. I am from NIT Karnataka. I am working on profiling driving behavior. I am using smartphone data to model the driver, like classification of how safe he's driving. This is what my research. I'm looking for a teaching job or postdoc. That's why I'm here. Okay, thank you, sir.
Hello, my name is Ritik. I hail from Assam only, from Guwahati. I have a job in the Volvo Group in the after sales industry, where we basically repair the vehicles using diagnostic tools. So a lot about these protocols we use it, including Bluetooth also. And one of my reason why I joined this course was because I had been searching for a lot in the basics of transport engineering. Something is available in our company also, but they deal mostly with policies and how to adapt the product itself, but not in this ground level of what is traffic, which is actually a very core subject. Something that I would like to share is like I'm a part of the network which actually believes in mass transportation. So, and Volvo being one of the first companies in India to adopt the FAME. The FAME is a scheme by the government which says like you could have more of these vehicles to to compensate for the transport needs of the general people. So I'm basically a practitioner of that, which means basically I use, although I have a private vehicle, more than 50% or 60% of the time I'm on a public transport, be it the metros or the buses. So this is actually a very fundamental course for me, but I think the needs are widespread. We are not able to produce a lot of products in India because the infrastructure does not support it. Otherwise, the technology is available, capability is available, people are ready to buy it, but we cannot. Lane support system, for example, is now a reality. All vehicles actually can be equipped, but we cannot do it because the adherence is not completely done. So there's a lot of other things that's going on, but nothing probably compensates for the basics of transport engineering, and that's why I'm here.
Okay, good.
Thank you.
So what is your background? Like,
I am basically a mechanical engineer. I had a job actually in IIT Guwahati from 2003 to 4 as a project engineer in the Department of Science and Technology under Dr. U.S. Dixit.
okay.
Yeah.
So good.
Okay. So good evening, everyone. I'm architect Apurva Nawani. So by profession, I'm an architect and transport planner, and currently I'm doing PhD in IIT BHU in architecture planning department under Dr. Harsimran Kaur. And my area of research is basically formulation of resilient transportation infrastructure framework to mitigate urban flooding. So basically, it involves the road network part of it, and I actually want to learn how to simulate it. So that is why I'm here. That's it. Oh, there.
Okay, good evening, everyone. I'm Abhinanda. I'm from IIST Shibpur, West Bengal. So I'm a PhD scholar. So my research topic is to create a framework for appraising the first and last mile connectivity by keeping in mind all the modes, necessary modes we have in Indian scenarios. So I'm here to attend this course. Thank you.
You are working with whom?
Shubhrata Kumar, Dr. Shubhrata Kumar.
In civil engineering?
No, sir, architecture.
Architecture.
Hello, sir. Hello, sir. Good afternoon, everyone. I am Pranay Kumar Mondol. I am also from IEST Shibpur. It is also known as B College Shibpur. So I am currently doing my PhD in the Architecture and Planning Department under the supervisor, Dr. Shomen Mitra. And my PhD topic is finding out the walking distance from a public transport stop. Generally, we follow the 400-meter criteria, which is a global criteria. But in Indian context, how much it would be, it is my part of thesis. So from here, from this course, I want to learn about the simulation and different techniques because it will be might be helpful for my thesis.
Good. Yeah.
Good evening, everyone. I am architect Arnab Chaudhary. I am an urban planner and I am working on inland water transportation, that is the freight transportation for the river Hooghly in Kolkata. And I am also from IIST Shibpur in architecture and planning, PhD scholar. I got into this inland water transport as I was working with MOVA, that is NIUA, and I was a sponsored candidate to work on the ferry transportation under Namami Ganga scheme. And from that, how I got into this freight transportation and all, and I am continuing with this work. And from this course, I was basically in search of how to get the data for freight transportation, the big data, and how to utilize that data.
We have discussed that it's very hard to get that one.
Hello.
Yeah.
Good morning. Good evening, everyone. My name is Japan. I am a master's student at IAC. I work more on the network side. So I just want to know the advancement in the other than what I am doing. I just want to know what else is there in the transportation networks. So that's why I'm here.
So with whom are you working?
Dr. Tarun Namba.
Oh, okay.
Yeah.
Namba, that's good.
So myself, Dr. Sunil. So I have completed my PhD in pavement materials. So, but now I want to shift my focus with respect to the traffic and planning. So I thought, let me attend this particular workshop so I can brush up my basics. And also I am pursuing my postdoc in Institution of Social and Economic Change. There I am working with respect to how traffic congestion is creating an impacts with respect to social and economic behavior of a people. So those things we are developing an econometrics models regarding this. So how to process these models and all, I thought I may get a broad idea about this by attending this workshops. Okay, thank
Uh, Hello everyone, my name is Deepak. Actually, I'm doing my research with Industrial and Systems Engineering Department, IIT Kharagpur. And in my research, actually, we are developing a decision support system for air cargo transportation, road planning system for military consignments. So the reason I'm here is because I want to enhance my knowledge in to develop or in the field of transportation. I'm very much interested in developing the mathematical model and simulation for road transportation, considering this impact of congestion. So actually, when I saw this advertisement, I thought this is a best starting point to learn these things, and that's why I'm here. Thank you.
So there's a lot of interest in simulation. Where you have pressure now on the last lecture simulation.
So it starts from there. Even though
I'm Anuj Bhaskar from Uttar Pradesh. I did my BTech from AKTU Lucknow. Now I'm pursuing my master's degree, and people don't know about me. This actually I run two startups,
Oh.
and I'm much more interested in softwares to know about techniques and all their AI things. So I love to manage things. So that's why my expectation from this course is to learn more about the softwares and all these things and how it will work, like Bluetooth, as you said, how it work. I'm too much interested in those things, so my expectation is this.
Good evening, everyone. My name is Satyam Kumar. I'm from Bihar. I did my BTech from Punjab Engineering College and currently doing Masters in Transportation System here. I want to learn about how optimization is done in transport networks.
Good afternoon, everyone. This is Nishat Tasneem, and I'm from Assam itself. And I did my BTech from NIT Silchar, and currently I'm doing my master's in transportation here in IIT Guwahati. Today, actually, we are not exposed much about transportation till now because we are just learning. So, I am more interested to know what's there in this topic, more about this optimizing transport networks. So, like, yeah.
Okay.
Thank you.
also join this session.
Good afternoon, everyone. I am Arshita Thakar and I am from Madhya Pradesh. I did my BTech from the State Government College and I am pursuing MTech from IIT Guwahati in Transportation Systems Engineering. So, yeah, actually, I want to know how to optimize transport network. So, I just joined the course. Thank you.
Good afternoon, everyone. I'm Megha Dangi. I'm from Madhya Pradesh. I completed my BTech from a state government college and I'm currently pursuing AmTech here in transportation systems and engineering. Why I'm in this course is I want to explore my interest in traffic sector. Like till first sem, I have been exposed to pavement and all now. So that is why I joined the course. Thank you.
So my name is Rohit Sahu, and I have a background of construction management, and I'm working on construction safety in worker safety in construction work zones. And Esper sir and Nibjyoti sir.
Now I understand what you asked about the construction question.
Hello everyone, my name is Ritesh Rao and I am working on understanding driver behavior and developing a threshold for rear end events, different stages of rear events like low risk conflict, near crash and crash using different surrogate indicators, and I'm working under Dr. Nibjyoti Bhardwaj.
Good afternoon, everyone. I am Shivasai. I am a research scholar here. My research area is like how the motorized two-wheeler behavior influence their safety using proactive approach. I have submitted my synopsis. So like I want to gain some like knowledge about how the data is there. So in my PhD, I have dealt with so much data like using videographic collection. So I want to explore like other data collection methods, and I want to gain some knowledge so that it will be helpful for my future research.
Hello everyone, my name is Pritam Shah and I am a MTech second year student here. I am working Dr. Nimjyoti sir and I am doing my MTech project on evaluating the safety implications of ADAS equipped buses by utilizing the real world data to uncover the patterns so that we can optimize road safety and operation. And I joined this course as I am from transportation system engineering, so have more exposure towards the transportation network. Thank you.
Good afternoon, everyone. My name is Arup Devarma. I'm basically from Tripura. I did my BTech from NIT Agartala, currently pursuing MTech here at IIT Guwahati. From this course, I was hoping to find some interest in traffic engineering to pursue my MT project in the second year.
Uh, Good evening, everyone. I am Sunil Chandra. I am master student here, and currently we are doing our coursework here. But our master's project, we need to decide some topic. I am very much interested in intelligent transportation system, so I need to learn something new in it.
Good evening, everyone. My name is Meghana Bhargav Saikia. I am from Assam and currently I am pursuing my master's in IIT Guwahati in Transportation Engineering Department. So basically, my expectation from this lecture is that so I want to dive into the various fields of traffic engineering so that it will be helpful for my master's as well as for my further studies. Thank you.
Good evening, everyone. Myself, Limosora. I'm currently pursuing masters in IIT Guwahati. I'm master's second year. My research is on the effect of geometric design consistency on driver's workload. The reason why I'm attending this course is because I'm just interested in learning new things. For example, we learned about occupancy, which was not means we had no I had no idea what occupancy is. Means we can like use occupancy in place of density in the heterogeneous traffic is so to represent heterogeneous traffic. So that's why like I'm pursuing this.
Good evening, everyone. Myself Shivam, and I'm MTech second year in IIT Guwahati only. So my MTP is under Moyesa only, and my MTP is titled as Development of Virtual Reality Scenario for Pedestrian Safety at Intersection. So the reason of attending this course is like it's every time fascinating to learn new things. Okay.
Good evening, everyone. My name is Akshay. I am from Kerala. I did my BTech from a government-aided college of Kerala itself. Currently, I am pursuing Masters in Transportation Systems Engineering, second semester in IIT Guwahati itself. Actually, Aglesa shared the details of the course. So when I saw the course, it was traffic related. So I thought of joining this course. Also, a professor, an honorable professor from Australia is coming. So I thought it would be good to learn new things like we will get an idea about what is happening in Australia and how we can incorporate it in India. So get a broader view. So thank you.
Evening, everyone. My name is Ichit Kumar and I am from Delhi. I did my BTech from Delhi itself in GGSIP University. Now, currently, I'm doing MTech and I'm in second sem in Transportation System and Engineering. The motive to join this course was to explore my interest in the field of traffic engineering. Thank you, sir.
Good noon, everyone. Myself Swarup Temre. I'm from Maharashtra. I did my BTech from RV College of Engineering in Bangalore, and I'm pursuing my MTech here. It's the second semester right now, and the reason I'm here, I am willing to join MTP under traffic, like preferably under Moria sir. So I'll try to learn more like, from here.
Good evening, everyone. My name is Vijay Lakshmi Rambam. I'm from Manipur. I'm currently doing MTech in Transportation System Engineering in IIT Guwahati itself. And as Akshay mentioned, sir shared the course link in the group, so that's why I joined.
Good evening, all. I'm Sharon C. Benny. I'm from Kerala and I did my BTech from a state government college in Kerala itself. Now I'm currently doing my second semester in Transportation Systems Engineering in IIT Guwahati. Like, sir has shared about this course, and then it would be better to explore the different aspects in this course. So that's why I joined it. Thank you.
Good evening, everyone. I am Sasiraj, currently PhD scholar at IIT Guwahati under Professor Akhilesh Maurya sir. The main reason behind joining this course to learn something about the how to analyze data and how to manage big data efficiently. So basically, the main motive is joining this course to learn how to get data from the field and how to optimize it in our research work. Thank you, sir.
My name is Niazuddin. I am doing PhD, pursuing PhD from this institute. I under Sharmila ma'am, and I joining this course because learn the advanced, recent advanced technology and what we need to advance that technology in transport system as well.
Good afternoon, everyone. My name is Daniel Lule. I am PhD scholar under Akhilesh Kumar Maurya sir. I am currently working on operational efficient electric vehicles, both comparing the conventional vehicle itself and both two-wheelers, four-wheelers, as well as the three-wheelers, e-rickshaws. My expectation from this course is definitely the data segregation. Actually, my stage is now on data segregation itself, and also I am most focused on sustainability. That will be more I expected from this course.
Good afternoon, everyone. Myself Sagnik, and I have completed my BTech from IIST Shivpur. Currently, I am pursuing MTech here and under Akhilesh Kumar Modia. And my project title is the inclusion of multiple leaders vehicle in the intelligent driver models. I have joined this course because I have also analyzed some big data like that collected from the drone. So that's why I have joined this course.
Good morning, everyone. My name is Yash, and I am pursuing my master's from here only on transportation system engineering. And my purpose of joining this course is to get some basic knowledge related to this topic. Thank you.
Good evening, everyone. I am Pankaj Kumar. Currently, I am Tech second year student at IIT Guwahati. I joined this course to enhance my knowledge on transportation network.
Good evening, everyone. My name is Mayank Sembal. I am from Uttarakhand. I am currently pursuing master's second year in transportation system engineering from IIT Guwahati only. So, reason of joining this course to learn about that is simulation course, simulation part.
So, online participant, if they wanted to introduce themselves.
Yes, I would like to introduce myself. Am I audible?
Yeah, we can hear you.
Yes, myself, I'm Ashwini Gupta. I am from Delhi only. I did my BTech from IIT Delhi. It was quite some time back. I graduated in 1982. Then I did my master's from University of British Columbia, Canada. And now post-retirement from government, that is Department of Scientific and Industrial Research, I'm pursuing PhD from Central Road Research Institute. And I am working in the area of optimization of Transport Sustainability Index of Indian cities with Dr. Erampalli Madhu. And since I'm working in the area of optimization and during the course of my PhD, I came across topics of obviously simulation and big data, and I was keen to know more about these areas, which would help me in my future journey to maybe add knowledge to myself and to wherever I join, maybe post my PhD, because I'm about to submit my thesis in CRRI, and possibly by the end of this summer, I maybe I mean, after I get my PhD, then I have to think about my future journey. And obviously, I met Professor Maurya and Professor Bhaskar at CTRG and also TPMDC, and I was very much interested to interact and add to my knowledge and also interact with other colleagues in this course. So thank you very much for this.
Yeah, thank you, Mr. Aswini. Yeah, now Mr. Sonu Kumar. Yeah, unmute yourself. Yeah, Mrs. Anupama.
Yeah, good evening, everyone. Myself, Anupama, and I'm working in AECOM in Bangalore. So, especially I'm in the transportation planning field, mostly working on modeling side of it. So, I did my master's from IIT Kharagpur, especially in the field of optimization, which involves mixed integer linear programming and all. So, I want to explore more in optimization in transportation networks, and I'm interested more to learn about it. Yeah, thank you.
Yeah, thank you. Thank you for the introduction. I hope you are able to hear all the audios and lecture slides clearly. Yeah.
Yeah, we could hear.
Yeah. Okay. So now we are taking break for 15 minutes and then we'll come back.